the positive integers a is less than b are such that a plus b over 2 and square root of ab are positive integers consisting of the same two-digit number in reverse order. What is the minimum value of a? All right, that means what they are trying to say is that it is like this. That means in this case, can you see that a plus b divided by 2 is actually equal to a, right? Therefore, a plus b is actually equal to 2a. All right, and your ab, square root of ab is actually equal to this number g lah. All right, then your ab will be just equal to g squared. All right, therefore I think you can think of it as sum of roots, and then this is the product of roots. Therefore I think we can use Vitas theorem, or the reverse or Vitas theorem. That means x squared minus 2ax plus g squared is equal to 0. All right, then from there you can actually solve for x. That means your x is actually equal to negative 2a, right? Negative of negative 2a, therefore you get 2a positive negative square root, and then this is negative 2a bracket squared minus 4ac, or 4ac, or g squared, and then from here divided by 2 times 1. And when you simplify, okay, let's simplify a little bit. Therefore this is 2a plus and minus 2, and then this is square root of a squared minus g squared, and then divided by 2. Therefore your x is just equal to a plus and minus square root a squared minus g squared. All right, therefore you can take a to be the bigger value, a plus square root a squared minus g squared, and then the b is a minus square root a squared minus g squared. All right, yeah. Then in this case, a minus b would be just equal to twice of square root a squared minus g squared. Therefore, a squared minus g squared. All right, and that will be just equal to what? That will be just equal to twice of square root a minus g, and then a plus g. All right. Then can you see that it has to be that means it has to be a perfect square, right? Because it says that a and b are positive integer. Therefore in this case it has to be this has to be that means in this case a minus g multiplied by a plus g has to be a perfect square, so that a minus b can be an integer. All right, therefore in this case a plus g and then a minus g must be equal to n squared, or must be equal to n squared. All right, and in this case, can you see that a is actually a two-digit number, right? That's what they say. This is actually a two-digit number. Therefore in this case, can I say let a to be equal to 10p plus q, and we can assume that p is greater than q lah. We can assume p is greater than q. All right. And then your g is actually q plus p, or the reverse, right? The reverse. Therefore a plus g is equal to what? Okay. Therefore okay, then can I say that a plus g will be just, you add together, you get 11p plus q. All right. And then a minus g, you end up with 9 p minus q, or p minus q. Therefore, I think the reason why we assume p is greater than q is because of this. All right, so that is a positive integer. Therefore, in this case, can you see that a plus g multiplied by a minus g is actually equal to 99 p plus q, and then p minus q, or p minus q. Therefore, what does it mean? And take note that this is actually equal to n squared. And in that case, can you see that 99 is actually 9 times 11. Therefore 9 is actually a perfect square, Therefore, this part here must contain a factors of 11. That means 11 must divide P plus Q and P minus Q. All right. And in that case, we take note. The only way is that P, because P plus Q is bigger, right? P plus Q is bigger. Therefore, we say that P plus Q is equal to 11, which is odd. Don't forget, P and Q are single digit. They are single digit. Therefore, P plus Q maximum can give you 11, right? Right. And P minus Q, and take note, this P plus Q is odd. That means your P minus Q is also odd. Is also odd because it is divisible by 11, or the product. Okay. And take note that in this case, P minus Q, because you see now P plus Q, this P plus Q now is actually 11. Therefore, now it is actually 9 times 11 times 11. Therefore, this part here must also be a perfect square, so that the product of this is actually equal to n squared. Therefore, can you see that P minus Q is also a perfect square? But the thing is, they are all single digit. Therefore, P minus Q can only be 1, can only be 1. Then in that case, can you see that based on these two equation, we can say that P is equal to 6, and then your Q is equal to 5. Then that means in this case, can you see that your A is actually 65, your A is actually 65, and then your G will be 56, your G will be 56. All right. Then in this case, remember class, what is A squared minus B squared, or A squared minus B squared, A squared minus G squared. Therefore, in this case, can you see that it would be square root of A squared minus G squared is actually square root of what? Is actually square root of 65 squared minus 56 squared. Therefore, I think you can actually do this. You can actually say that is square root of 65 plus 56, and then 65 minus 56. All right. Okay, I think in this case, you will get what? You will get 121, 121 multiplied by 9, square root, and that is actually 11 multiplied by 3, and the answer is 33. The answer is 33. Therefore, now remember, our A is what? Our A is actually this one, right? Our A is our small a. Okay, sorry. Our small a is actually this one. Therefore, now can you see that our A is actually A plus square root of A squared minus G squared. Therefore, in this case, can you see that your A is actually what? Your A is 65, right? Plus 33. Then in this case, that will give you 98. All right. And then what is your B? Your B is 65 minus 33, and that will be 32. All right. But the thing is, can you see that basically A and B are the root of this equation, right? A and B are the roots of this equation. And they ask for what? They ask for the minimum value of A. The minimum value of A. Therefore, I think, and can you see that I did it the other way around? By right, A should be less than B, right? Therefore, now can I say that you change this to B, and then you change this to A? Therefore, this is A, and then this is B, sorry. Therefore, the minimum value of A is just equal to 32. That means we take the smallest roots to be A. Oh, do you get me? Because I think A is supposed to be less than B, but when I calculate, I get my A to be bigger. Oh, therefore I think I forgot about this. Oh, that means I should do it the other way around. I should say A is A minus square root A squared minus B squared, and then B is actually A plus square root of A squared minus G squared. Oh, that should be the correct way. Oh, but I think I swap around. Oh, but actually the concept is the same. Therefore the minimum value of A is actually 32. Yeah.